Okay, problem 102 gave you this matrix, asked you to write the corresponding system of equations. Now remember, this matrix represents, well, commas separate numbers in rows, and semicolons separate rows. So every time you see a semicolon, you start with a new row. So we do a row 7, 4, 1, negative 3. We don't write the commas, 7, 4, 1, negative 3. And then we start a new row. Negative 8, 16, 2, negative 12, right there it is. And then we start a new row, and you see that those numbers are there. So what's the system for this matrix? Well, the system is 7x plus 4y plus z equals negative 3. It's an augmented matrix. You're told that it's an augmented matrix, so you know that you have an augmentation. What's to the right of the matrix is to the right of the equal sign. Okay? And then you just write the rest of the system, because the first number always is the coefficient. The first number in a row is the coefficient of your first variable. Second row, second variable. Third row is the coefficient of your third variable. So here we have it, and I think everybody understands this quite well. There's our system. Now, of course, we can row reduce, or we can reduce the system using elimination. For example, we could add this row to twice this row and remove our x term. Okay? Now, we usually want that to precede whatever we have up here. And actually, never mind, we could, we could do that. We could replace this row with what we get when we add this row to double this row. We'd have zeros for our x. We'd still have our x term down here, and we wouldn't be able to remove that at the same time. We could take 1/7 of this row, which would give us a 1 in front of x, and then multiply that by row by negative 4, or not row, but equation by negative 4, and add it to this, and that would eliminate the x down here. So we'd have no x's in these rows. We can then eliminate y's. Okay? We might want to switch these two rows and then take 1/2 of this row and add 32 times, add negative 16 times what we get to this one. Well, you get the idea, and this is something that at this stage, because we're just reviewing for the test, everybody should be very familiar with, and I emphasized in class. You have to know how to do this, and this is only a matter of practice. This is not a high-level skill. Okay, you've done stuff of much greater complexity in your calculus course and in other courses. And you also have to know how to reduce a matrix, which is identical to the way you reduce the equations, are practically identical. The operations are completely analogous. So you have to know how augmented matrices represent systems. Okay? You have to know how the left-hand side of this matrix represents these three left-hand sides. Not the left-hand side, but the first three columns of this matrix represent the left-hand sides of these equations. Absolutely essential. Then you have to know what you get when you reduce them. Okay? It might be that in reducing these, in eliminating your variables, you end up with an equation that reads something like 0 equals 5. What does that mean? Well, that means that there's no solution. It means that one of the planes corresponding to one of the rows is parallel but not overlapping, parallel but different from the plane of another. And we'll talk about that a little bit more. You have to know where this is headed, but for right now, you have to know how to write the matrix as a system, or write a system as a matrix. Everything depends on that, and then on other things as well.